the reason why I didn't use this one is that when you do fuzz testing, it's difficult to compare the efficiency of one specific area of fuzzing to another specific area of fuzzing. There's more than how much did it say actually? There's tens of thousands or hundreds of thousands, 705,000 unique fuzz test cases in our HTTP test tool by default, and just running these in single-threaded mode or multi-threaded mode is done in a best effort way. So some test groups run much faster than the other groups where, for example, the web server is not responding at all and we need to wait until timeouts to actually get responses from the web server. Sometimes we get fast responses, sometimes we get slower responses. So doing a comparison of fuzzer performance is usually safer to do with valid sequences instead of the actual fuzz test cases. Fuzzing is almost always significantly faster than running valid cases because you can optimize the timeouts and you actually get more test scenarios where you don't actually even get many responses. And even when you're testing, especially when you're testing complex protocols like TLS, SSL TLS, the message sequence is often aborted immediately after the anomaly is sent. So for example, if in the hello message already there's a completely anomalous non-conformant element, the TLS server will reject that, abort the sequence there, and the fuzzer is therefore 6 times faster than actually running the valid case. So therefore I chose to use valid cases instead of using the actual fuzz tests, but I can leave the fuzz test running here as well, and we can immediately see that it should be, well, not in this setup, but we can see that it will be significantly faster. But I'm happy to answer if this didn't clarify, then I can, of course, go into more detail as well.
Okay. Yeah, I think that clarified that. But if you have more questions, please send them through the chat window. But to other questions, so you talk about using fuzzing tools, performance testing, and on the other hand, using performance tools for performance testing while using fuzzing tools for fuzzing. So can fuzzing tools really be used for performance testing, and what do they bring to performance testing?
Fuzzing tools can be used for performance testing as they are. So with all the valid cases especially, you can create almost all the same test scenarios that you can do with performance tests tools. And in addition, you can use the test case editors and you can create your own test scenarios as well. But the biggest addition that fuzzing brings to performance testing is some of those unique test cases that actually cause problems in the test execution. So for example, now I finally have the fuzzing running, not extremely fast, but we can see that it's actually running significantly faster than the valid cases anyways. We can then analyze the test results, and we can look at timings, and we can see that some test cases take a lot more time to execute, and then we can select any one of those test cases and either use that as the performance test case to find those bottlenecks, real bottlenecks from the system, or then alternatively you can actually save those test cases and load those same test cases into your performance testing platform as well, and then run them really fast. So fuzzing is more used to identify those anomalous test cases that use a lot of CPU power or memory from the test target, pinpointing those, and then being able to run those faster, whatever platform you choose to use.
Okay, thank you. And what kind of issues can you find with a scalable fuzzing?
Of course, you can find increased amount of crash level issues in the systems, and that's because often when you run anomalous test cases in parallel, the end result is more than running them individually. But most importantly, you can actually find memory leaks, you can find performance issues in the systems, and you can optimize performance capability of the system. And the reason why many people do that is that if you look at this from hackers' eyes, attackers' perspective, if they can identify a single input that, for example, creates a lot of CPU processing on the test target, then of course, instead of doing distributed denial of service attacks using valid requests, they will use anomalous requests, and they don't need to create that many bots, or they don't need to use that many bots or create that much traffic in order to cause the same or even increased amount of processing on the target system. And on the other hand, what also people do this for is to identify inputs that where you send a small piece of data. Let's see if we have any examples here. Let's stop this and look at the results and look at how much data we receive per test case. So for example, in some cases you send extremely small input, but you get much larger return from the server, and these type of test scenarios can be used for amplification attacks, where you fake to be someone else, send a request, and the response actually attacks someone else. So in performance test scenarios, you still need to plan your tests. You need to build those test scenarios, and you need to have a test purpose. And then software-based tools are flexible in creating those test scenarios either in low load or high load, or together with other load testing tools.
Okay, thank you. And next question, for what types of protocols can you use high-speed fuzzing?